So now we're going to be using integrals for different things. For example, in here, finding the area between curves. So this is a parabola. This is a taller parabola. And then this one is a line. So it would be y equals negative 4x plus 4. So it's crossing the y-axis at 4. It's then going down with a negative slope. And find the area that's bound by all three of those in quadrant 1. So that would be this region in here that's between all of them. So then this creates an interesting problem in that when we integrate, you integrate and you take the top function minus the bottom function to find the area in between. Well, when you're here, that means it's the red parabola versus the blue parabola. So it's going to be 8x squared minus 3x squared. But by the time we get over here, it's going to be the line minus the blue parabola. So we're actually going to have to break this into two integrals, and they are going to be split right here, where the line and the parabola meet. So the first thing to do is find out where that x value is, and then we're going to have to stop the integration right here, which is where the line and the blue parabola meet. So we need that x value as well. So we need to find out where this line meets each one of these. So for the line versus the red parabola, I'll use red. So it's going to be, let's see, we've got that y is equal to this. We can substitute that in there. So negative 4x plus 4 equals 8x squared. And so this is going to be 8x squared plus a 4x and minus a 4. And then we would have over here, where does the blue parabola meet the line? So that's going to be essentially the same thing, except it's equal to 3x squared, so it's going to be negative 4x plus 4. Where does that meet 3x squared, the blue parabola? Just to save a little bit of time on this podcast, I'm not going to do the quadratic formula to find these. I'm going to use the calculator. So we've got 3x squared, 8x squared, and negative 4x plus 4. The window from 0 to, let's see, if y was equal to, it looks like 0 to 1. Let's see. There is one parabola, two parabolas, and a line. Okay, so calculate, find out where they intersect. So I want that one right there. Oh, it's right in the middle at x equals 1/2. So we'd have x equals 1/2, and then for this one over here, calculate where they intersect. At 2/3. Okay, so we have to find this area in here. It's going to be the red parabola minus the blue parabola. So we're going to integrate the top one minus the bottom one. So 8x squared minus 3x squared. And that's going to go from 0 to the first one we got, which is 1/2. And then add to that the next integral, which is, so over here it goes from the lines on top minus the blue parabola. So it's going to be the line minus the blue parabola, top minus bottom, with x going from, so from the middle 1/2 over to 2/3. So from 1/2 to 2/3. Well, that took a bit of work to get it set up, but the actual integrals are going to be pretty easy. This one is going to become x to the 3 over 3 with an 8 still there. This one will become, well, this is actually the derivative of x cubed. Because it would be, I guess I could have just done algebra first. Oh well. That's fine. And then evaluate from 0 to 1/2. So this one would become x to the 2 over 2, but that's going to divide into this, leaving negative 2x squared. The middle one is a 4x, and then this one is from x cubed. And then evaluate from 1/2 to 2/3. So substituting a 0 in here will do nothing. Substituting a 1/2 will make this 1/8 once you cube it. The 1/8 will cancel that 8. It'll leave only 1/3. And then this will be 1/2 cubed, so 1/3 minus 1/8. And then add to that. So this is going to be 2/3 first of all, so that's 4/9 times a 2. This is going to be 2/3 substituted in there. And then 2/3 cubed is going to be an 8 over 27. Alright, now substitute a 1/2. So that would be 1/4. Multiplying by that makes it negative 1/2. Half of 4 is 2. And then 1/8. So let's see, in total we've got, oh, by the way, if you look at the graph, so this goes from 0 to 1, and this goes up to, right there is a height of 2. So if it was this whole lower rectangular region, that's a rectangle that's 2 by 1, so the area is 2. And then this is maybe, what, less than a half, quarter of that. So 1/4 of a 2. So I would say it's going to be, the answer is going to be less than a half. That's just my geometrical guess. Less than a half. So let's see, I've got 1/3 minus 1/8. And then plus to that okay, and then minus parentheses negative 1/2 plus a 2 minus 1/8. And I thought that the answer would be less than a half. Let's see. Yeah, a little bit less than a half. Or if you would like to have that as a fraction, 17/54.